Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning, everyone. Today I want to discuss ecosystem services and how urban green infrastructure can deliver those services in cities. When ecologists talk about ecosystem services, they generally mean four categories. Provisioning services supply material goods. Regulating services control environmental processes. Supporting services maintain the ecosystem functions that make everything else possible. And cultural services provide recreational and aesthetic benefits. In an urban context, these categories have very practical implications. Provisioning might be community gardens or urban food production. Supporting services include habitat patches that sustain pollinators. Cultural services include parks that improve mental health. And regulating services are perhaps the most immediately measurable, because they alter things like stormwater flow and temperature. When we talk about regulating services in cities, we mean things like stormwater management and urban heat mitigation. Let me give you some specific examples from applied work. Green roofs have been widely studied. In Chicago, a program of small-scale green roofs was associated with a reduction in summer cooling demand on the buildings below. One study estimated roughly a 10% drop in building energy demand during peak summer months for retrofitted roofs. At the neighborhood scale, tree canopy increases evapotranspiration and provides shade. This combination can lower surface temperatures by several degrees Celsius on hot afternoons. That reduction translates into less energy spent on air conditioning and a reduced urban heat island effect. Stormwater control is another clear regulatory benefit. Permeable soils, bioswales, and constructed wetlands slow runoff and increase infiltration. For example, restoration of wetlands and retention basins in parts of Seoul reduced peak stormwater flows by about 30% in intense rain events, which lowered the frequency of street and basement flooding. Air quality is also affected by vegetation. Leaves capture particulate matter and some gaseous pollutants. Urban trees and green walls have been estimated to remove measurable amounts of nitrogen oxides and particulates over a growing season, though the numbers vary by species and local conditions. Of course, there are trade-offs and constraints. Green infrastructure requires maintenance. Soil depth limits what plant communities can survive on a roof or in a bioretention cell. And in some dense urban areas, land tenure and competing development pressures constrain implementation. Economic considerations matter. Upfront installation costs for green roofs or street trees can be significant, but when planners evaluate life cycle costs, they often find long-term savings through reduced energy demand, avoided stormwater treatment costs, and increased property values. Policy and design examples show what is possible. Singapore provides a national-scale example of integrating green infrastructure into dense development, with incentives for vertical greening and mandatory tree planting in new projects. That approach demonstrates how regulatory frameworks can support ecological outcomes at scale. On a smaller scale, community-led projects like New York City's High Line or local wetland restoration projects illustrate cultural and recreational co-benefits, which strengthen public support for ecological investments. To evaluate these systems, we use a combination of tools. Hydrological models estimate runoff reduction. Remote sensing provides canopy cover and surface temperature data. Social surveys measure perceived benefits and use patterns in parks and greenways. In summary, urban green infrastructure provides a portfolio of ecosystem services. The key for planners is to quantify both ecological and social outcomes, to design for local constraints, and to integrate maintenance and policy instruments so benefits are sustained over time. Next week, we will examine specific modeling techniques for estimating stormwater retention and discuss a case study in more detail. For now, think about how the different types of services might be prioritized in your own city.
Listen again to part of the lecture. Then, answer the question.
When we talk about regulating services in cities, we mean things like stormwater management and urban heat mitigation.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.